So this is lesson 2 from unit 16, and we're going to continue looking at complex numbers. First of all, this is just a little algebra 2 review. If I ask you to solve this using the quadratic formula, then we can define a, b, and c. We can plug those numbers into our quadratic formula. And when we do that, we get 16 minus 32, which is negative 16. And before this chapter, we've always just said at this point no solution, because you can't do the square root of a negative number. But now we know that we can indeed do that. So this is going to be 4i, and plus or minus 4i. Also notice all these terms have a factor of 2, so we can divide the 2 out as well. So negative 2 plus 2i, or negative 2 minus 2i. And this also reminds us of another important rule when we're solving an equation. If we have a complex solution, then we also know that the conjugate is also a solution to that equation as well. As you can see here, it's just a change of sign within here. Now we could also do that question by completing the square. So if we complete the square, we do half the coefficient of 4, which would give us 2. And then we say 2 squared is 4. We don't want 4 though, we want 8, so we also need to add on 4. And then we can start rearranging this. So bring the 4 across, square root of both sides. As it's a negative number, it means it's going to be 2i or negative 2i. Instead of adding 2 to both sides, subtract 2 from both sides. And we should be able to check that that's exactly the same answer that we just had a second ago. And probably a lot simpler actually. So completing the square is actually very useful for solving questions when we have complex solutions. Now a slightly more complicated one, just to remind you when you complete the square. If we're going to do it when the leading coefficient is not 1 for x squared, then we should take 3 as a common factor. But only for the first 2 terms. Well, that'll be my recommendation anyway. This is supposed to have an x here. Then we can do half the coefficient of 2x, which is going to be 1. So we've got 3 times x plus 1 squared. Then we just got to make sure this works nicely. So 1 squared is 1, times by 3 is 3. We don't want 3 though, we want 4, so you need to go ahead and add 1. If you have forgotten the work on completing a square, go back and look at the video on YouTube. It's AICE 1 Chapter 4, and it's one of the most watched videos actually. Now we can go ahead and solve this. So subtract 1 from both sides, divide by 3, negative 1/3, square root of both sides. So rationalise as well at the same time. So the negative square root tells you it's I, square root of 1 over the square root of 3, we can rationalise, and then subtract 1 from both sides. So useful method to remember when we're actually doing these questions. Now we talked about this last lesson, but just a reminder, z is going to be a complex number, and z star is going to be the complex conjugate. So if z is a factor, then z star is also a factor. Fully factor this. Now this actually looks more like chapter 1 from AICE 2. So one thing we have to do to begin with is we have to find a single factor. So first of all, I'm going to try 1. What I'm looking for is numbers that divide into 26. So probably 1, 2, 13, and 26. So it's probably going to be plus or minus 1 or plus or minus 2 seems quite likely. And possibly 13 within there as well. Of course, there could be a complex solution as well, which we'll discover in a second. So if we plug 1 into that formula, we get negative 40. So that's no good, that's not a factor. If you plug negative 1 in there, we do get 0. So that tells you that's a factor. That tells you that that's a root. Therefore, we can use that to help us find out what this divides into. So, using synthetic division, and these numbers here came from the coefficients of the question: 1x to the 4, 3x cubed, 7x squared, negative 21x, negative 26. And then when we do our when we do our synthetic division, we bring down the 1. Negative 1 times 1 is negative 1. We add these two numbers together, so that should be 2. Negative 1 times 2 is negative 2. Add those together, that gives us 5. Negative 1 times 5, negative 5. Add these two together, it gives us negative 26. Multiply, 26. And we should, of course, get 0 on the end, because that's the definition. If it's a root, then when we divide in, we should get a remainder of 0. So this actually working backwards, negative 26, 5x, 2x squared, 1x cubed. So we've got something a little simpler now. Also, as the question said factor, we're going to do the opposite sign to the root. So we've got x plus 1, x cubed plus 2x squared plus 5x minus 26. And now we have to try and factor this. So to do that, we're just going to do the same thing that we just did a second ago. We're going to try some numbers. There's no point trying positive 1 because we already know that doesn't work. So negative 1 should be our first number. And this time that doesn't work. So let's move on to positive 2. Positive 2 does indeed work. So, oops. Let me just get rid of that. So we're going to go ahead and repeat using synthetic division for a second time. So the numbers here, once again, come from these numbers up here. Let me lower this a little bit. Oops. So bring the 1 down. 2 times 1 gives me 2. 2 add 2 gives me 4. 2 times 4 is 8. 5 add 8 is 13. 2 times 13 is 26. And add them together and we get 0. So 13, 4x, 1x squared. And we've managed to get down to this stage. Once we get down to a quadratic, we should be able to factor that a lot easier. What's probably going to happen with this question is, though, it's going to be something that's complex. So it's going to be a little more complicated to work out. So let's look at our final part here. We're down to this stage. We're trying to factor this. And here's the clever step for this one. We're sort of completing the square here. So we've got x plus 2, half the coefficient of 4 is 2, 2 squared is 4, we don't want 4, we want 13, so we want to add on 9. But now both of these are perfect squares, x plus 2 squared plus 3 squared. So we can actually write this as x plus 2 plus 3i, x plus 2 minus 3i, using that difference of squares. So that's how we would go ahead and factor that. And there's just my little steps there as well on the side. So a much longer question than what you originally did when you covered chapter 1.